Good morning. Ohayo gozaimasu. This is a great pleasure for me today to make a presentation of one of the priorities of HFA1, which is the public investments in the infrastructure of the in DRR. This I will be presenting on behalf of the National Delegation for Major Risk in Algeria, public investment in infrastructure to the reducing flood disaster risk in the district of Bab El Oued in Algiers, Algeria, which I believe was the starting point for the whole strategy for disaster flood risk reduction for the whole country. This is the November 10th, 2001 Bab El Oued flood, mud and debris flow, which is the city center, an urban site. Historically, the area, before to go to historically Bab El Oued, which is in Arabic, the door of the river. This is give us something to think about. Is somebody will accept to live in the door of the river? Historically, this area has experienced abnormally high rainfall events, but that of 2001, 260 millimeters is far by the highest. On 31st of October in 1911, 134 millimeters. In September 34, 101 millimeters. And in November 1935, 129 millimeters. And in April 54, about 135. But on the night of the 9th and 10th of November 2001, a violent torrential rain hit the province of Algiers, the capital, and particularly Bouzaria zone with a total of 260 millimeters, that is 260 liters per square meter. In 18 hours, in the station of Bouzaria and Cap-Capcine. On the normal, November does not exceed 96 millimeters. At the height of the phenomena, the rainfall had a duration of about 1 hour and 30 minutes. And this is the flood which caused like 776 human lives lost, 350 injured, 160 missing, 800 housing units suffered damage, 1,500 families made homeless, 60 schools, scores of bridges, roads, public works were damaged, more than 1.4 million cubic meters up to 10 meters high, thick of mud in the street of Bab El Oued, more than 350 vehicles, cars, trucks, and buses with passengers buried under the debris flow and mud. Main sewers and drainage system were completely clogged, significant damage to water, electricity, gas, and telecommunications. The preliminary cost of this disaster was $250 million US. This is some photo of the damage, what happened in the city center. That is the urban risk in floods. And you can see here, this is an expressway just in the bed of the river. You can see this is the expressway, and you see the cars, what happened this night. Here, the damage to the public infrastructure, and you see the mud here in the city of Bab El Oued. This is you can see here the cars, floating cars and trucks in the expressway of Frivalo in Bab El Oued. This is, this is some picture of the disasters. And this is what happened really in the catchment. You can see here all the catchment coming to this is what we call Bab El Oued, the door of the river. And you can see the water coming and the swell of the water coming up the other side. Then the water came up here about 10 meters high with floods and debris flow. Here the study of vulnerability. After the disaster, we have made vulnerability studies to see what are the zones, vulnerable zones. And this is what we found, the vulnerable zones. This is the Bab El Oued is here. You can see the river. And this is where the risk is high, moderate risk, and and lightweight. And this is what, after just following the disaster, this is what we have done, the government has done, is the following measures implemented to the Oueds. Oued is like a river in Arabic, and floods, as flood risk reduction, by cleaning out, recalibration and reprofiling, placing the gabions, enlargement of beds, achieving reception structure, retaining structures, realization of settling pounds. And this is the rivers which contribute to all these Algiers here, and Bab El Oued is about this way here. Now this is the catchment most affected, and most affected the city of Bab El Oued. Then this study that has been made, and this is what we're gonna, and this is the part of the city which suffered a lot. Then the government decided to have a project to invest in public money in this region of Algiers to reduce the risks. This is the project of duplicating the collector of Oued Mkessel. Oued Mkessel, which you can see here, all these, about 5 kilometers to duplicate it, in order to absorb in the future disasters the river. And this is the catchment of Oued Korich, which was most affected. And you can see here all these, and here you can see civil engineering structures, which I'm going to show them. Here it will be a tunnel, just a tunnel made under the city. And here you have in the blue things here, we will have an open sky frames for the water. And this is the catchment, 9 kilometers square. And this is what we are trying to do to catch all the water and to bring it to the sea. Civil engineering works, this is and the main constraint when you do that in the city, in the urban side, the hydraulic constraints to high flow rate, like 63 cubic meter per second, protection of works against the erosion, effluent limitation speed from 5 meter per second to 7 meter per second, limitation of slope, because the slope is very, very high, of the collector between 0.5% to 0.88%, except for the first section where the slope is 6%. Water well vortex or bearing waterfalls. These constraints must be integrated in the hydraulic study of the region. Then constructive and environment contract, few sites available for location of wells and construction facilities. Reduced space, sinuous courses, and you can see what they have been done here in the city of Algiers. This tunnel, which will be the new collector or duplicating collector for the one existing already. Depth of wells, more than 50 meters, conducted in the rocks within the city. You have use of explosive prohibited because we are in the city, and traffic restriction, of course. Protection against the swell of the sea, because the sea is coming in the door of the river. And this is the project you can see here. This is, you can see the wells here, the waterfall wells. This is the slope going from 220 meters for the above the seawater to 4 meters. This is the slope, it's very high. And this is the wells, the waterfall wells, 20 meters, about 5 kilometers up to here. Then you have an open sky frame for the collectors. This is blue. This is an open sky, which we'll see how science and technology can contribute to disaster risk reduction. And this is very important since we are in this post-2015. We see how science could and should contribute to the disaster risk reduction. This is the average depth of water line, 30 to 35 millimeters. That's very deep. Okay. Accumulated heights of all of wells, 50 meters. Accumulated height of the connection wells, 150 meters. And this is the type of waterfall well and vortex at Joubert. This is what has been constructed in this city for, because we have the slope, we need these waterfall wells. This is made by these norms, and you can see the helical cantonment, well vortex, and chamber of dissipation. See, the depth is 53 meters, and we have this is the technique that has been used, how complicated and sophisticated this technique has been used in the city of Algiers to reduce the disaster risk. And we see here the political engagement to reduce really the risk in the city. See, 44 meters of the wells, and you see these connecting tunnels, interception rooms, the interception room avoid. This is all the techniques of the tunnel, the new tunnel here, and the waterfall. You have the bearings here, waterfall bearings. The gallery of junction, the drift removal, sand and gravel. Yes, and you have the chimney, access chimneys for the people there. See, the depth is 23 meters. Testing, of course, this has been tested in the laboratories before implementation because it's very expensive, this project. And this is the vortex, how the water will go to the tunnels. And you see all these testing models that have been tested in laboratories. This is the collector of open sky. We have the tunnel, we have the open sky. This is the tunnel which is made in concrete, of course. You can see it here also. This is to reduce the future disaster risk floods. In water, see, it goes from within the city with all difficulties to the sea here. And you see the material, the complicated material that has been used. And this is very important to the swell of the water cannot come back like last time. Then we have the flow coming to the sea. This is the wells that have been made and excavated in the soil. This is see how strong is this civil works, and you see how deep also, 53 meters going in the city. And this is the machine we made. This is the tunnel. This is what the new collector of the sewage system. And this is you see the tunnel with the well, the junctions. See the tunnel and all the junction of the canals. And this is to the sea, to the junctions, chambers. This is the vortex which has been tested in the laboratory. Now it's here in reality. Civil engineering is complicated and sophisticated thing to be installed. This is the excavation for the tunnel excavation at 83,000 cubic meters, concrete 28,000, steel 2,000 tons. I go quickly. Then in the wake of this disaster, the Algerian government allocated for disaster fraud reduction strategy across the whole country a total budget of 3.6 billion US dollars. And the total cost of this project, the total cost of this duplication of the collector Wedenkessel was 74 million US dollars. This is a huge project in terms of And I like, this is how Bab El Oued was built. This is building, Bab El Oued was built better Bab El Oued. Okay? Now this is how it looks, Bab El Oued, and you can see the protection here. They made the parking, and I think I finished on time. Thank you. Thank you very much.